violently volcanic. How did these bodies form, and what is their history? What can this giant planet tell us about the history of our solar system? Dr. Torrance Johnson, project scientist.
Well, Jupiter itself, of course, we believe to be composed primarily of material that's very similar and virtually unchanged in the last 4 billion years to the material that formed all of the planets, the fundamental solar nebula, if you will, the gas and dust from which all the planets formed. In addition to which, the satellite system surrounding it, its magnetic field environment, make it virtually a miniature solar system. And so by studying this system, we can learn a lot about how the solar system as a whole formed and something about our own origins.
Galileo, the new generation spacecraft, is designed to spend an extended period of time in the Jovian system. The spacecraft will release a probe to fly its own trajectory to Jupiter. The orbiter is then targeted to its first encounter, Io, a moon known to have very active volcanoes. Then the orbiter points its relay antenna toward the probe, which begins its descent into Jupiter's atmosphere. Once there, it will investigate the composition, temperatures, and pressures at varying levels and send data back to the orbiter, which will retransmit it to Earth. The orbiter will loop through Jupiter's system, measuring and observing the giant magnetic field and plasma, as well as the intense radiation that surrounds Jupiter, while performing closer studies of the moons. The combination of closer encounters and advanced instrument technologies carried on board Galileo will give much better definition of surfaces than ever before.
Specific major advances that we've made is in the camera system, where we're using the same optical system, same telescope, if you will, that Voyager did, but instead of having a relatively slow and insensitive Vidicon tube, such as was used in TV cameras in the 50s and 60s, instead of that, at the focus of the telescope, we now have a silicon-based device, a charge-coupled device camera system, which gives us a increase in speed or sensitivity of the instrument of between 300 and 1,000 times. That allows us to take much higher resolution pictures much closer without blurring, and it also gives us access to a little bit of the infrared part of the spectrum that was totally inaccessible to the Voyager's cameras. Now, in addition to that, in the infrared, we have an entirely new device called the near-infrared mapping spectrometer, which, if you will, is a little bit like a Landsat-type device, giving us images in many different spectral bands. And we'll have about 300 different spectral bands. What this means is we'll have, from this device, pictures with relatively modest resolution spatially, but with where each pixel element within the picture will have a 300-channel spectrum attached. We're going to be using this on both Jupiter and the satellites to map composition on their surfaces, study the characteristics of Jovian clouds, find out where ices are on the surface, try to identify the materials frozen out on the surface of Io, for instance.
En route to Jupiter, Galileo will pick up energy by utilizing gravity assists while traveling once by Venus and twice by Earth. In addition to the bonus of studying these two planets and Earth's moon, Galileo will perform close flybys on 1 or 2 asteroids, never before closely observed. Then Galileo will rendezvous with Jupiter and its moons in 1995. This unique trajectory will allow Galileo to reach its ultimate goal, returning a bonanza of scientific knowledge and discoveries from Jupiter's system.
Hi, Neil Armstrong.
Leonard Nimoy.
Orange County Shoppers.
Super Warner.
The robot.